Hey guys, welcome back to the Pre-Trained Pod. My name is Rich, AI research scientist in the Bay Area.
And I'm Pierce Freeman, AI founder based in the Bay Area. Rich, we really need to come up with a combined tagline now that you're back. I feel like for a while it was the whole Cambridge, San Francisco thing.
Yeah, I mean,
We're just both based in the Bay Area.
we're
now.
just dudes in the Bay Area. How about that?
We're just a couple of neighborhood
A
guys.
couple of friends hanging out in the
hanging out in the
neighborhood.
Bay.
All right, Pierce, it's my turn today to show you some of the cool stuff I've been up to. I want to just say right off the bat, this is probably going to be something I want to talk about for at least 2 or 3 of these shorts because it's a kind of a big project. This is something I was actually working on during my PhD. It's the very last project I worked on. This is something I've been tinkering on for at least a year and a half at this point. So there's a lot to say. But today what I want to do is I just want to give you the high level overview of this thing I built called Pico. So Pico, you can think of it as this language model development toolkit. It's this way for you, if you're trying to develop a language model, to develop this language model in a more scientific way.
Okay.
Okay, what do I mean by that? So in research and in industry, but mostly in research, when we're developing language models, when we have some take and we want to develop a new language model, the approach we do is typically we just kind of like try out 10 different things and hope something works. That's what we do.
It's a dirty little secret of ML research.
Not very scientific, man. And especially in industry, if you got your boss kind of breathing down your neck, chances are you're just going to test out the 1 or 2 things you think are going to work, hope for the best, hope you don't get fired, and hope to God that it improves the accuracy.
Totally.
Right? It's not very scientific.
You'll like grid sweep a bunch of hyperparameters. If the loss goes down,
You're kind of happy.
Right?
And let's say it works. You don't really know why it worked. It's just kind of what it is, and then you ship that into production and just loss went down a little bit, right?
It's kind of like why sometimes some people describe like the ML researchers in San Francisco as casting these spells. Like that's sometimes what it feels like even when you yourself are the ones casting spells.
Yeah, the idea is like, you have this like magic, which is like a language model working correctly. And the engineers are these wizards who kind of like know how to like speak the right spells and get the thing to work somehow, right? It's like the whisperer of language models. Pico is designed to make it easier for anyone to develop a language model in a way that is more scientific. And so part of the problem that I see with how we develop language models is that we don't have a good scientific understanding for how to evaluate whether or not a language model is working well or not. Like there's no good way for you to introspect into the learning process and for you to be able to say, hey, this language model is learning well, or this language model is not learning very well. There just aren't really good metrics. There's no good way of like introspecting into the weights of a model, whether or not it's learning well. And how do we even evaluate what it means for a model to learn well, right? These things are all very amorphous. And what I envision is basically creating a toolkit that allows you to build language models that treat interpretability as a first-class citizen. So that means to say, like, have a language model where as you're designing the model, you build in the scaffolding that will allow you to really easily introspect the learning process post hoc. And that's what Pico is. So Pico are these 2 libraries, Pico Train and Pico Analyze. Here, this is the website, picolm.io. Feel free to visit it, give it a shout out. But we can take a look at the code. So when you look into the Pico Train code base, you can see that I've implemented out of this box.
Dude, you've got 300 stars on this.
I got 300 stars
This is
on
kind of a thing.
Ain't nothing but a chicken wing. If you look at the code, picodecoder.py, you'll see that I've implemented out of the box this model that I'm calling Pico Decoder. Now, I want to warn you, this isn't a state-of-the-art, with all the bells and whistles model. But what this is a very well-documented, minimal implementation of something that can be a state-of-the-art model. So the idea here isn't that you take this and you build a company that's worth $1 billion with this out of the box. No, rather the idea is you fork this, you tinker with this, and this is your starting point for developing your own language model. This is like what you want to start with. So that then you can add all of the extra bells and whistles that you might want to add. The only thing I've added in here, I think, are the bare building blocks that you need to develop a good language model. So that is things like grouped query attention, rope embeddings, pre-layer normalization, all of these like very basic things that all state-of-the-art models come with out of the box. Then you can go ahead and just add whatever else crazy thing you want to do with it. But the nice thing about this Pico Decoder model is that out of the box, it comes with some of these hooks built in that allow you basically to, as you're training, hook into the model and over the course of the learning process, dump out really important statistics that will let you, after the model's trained, introspect the learning process so that you can look at what was happening with the gradients over the course of the training process. What was happening with the attention weights? Can we look at, for instance, how fast the attention weights converge to a given representation? All these things are easy to do, but you have to be careful. At the very start, you have to make sure that you've introduced all these hooks into the model at the right spot. Otherwise, you won't be able to do this analysis. With my model, you have that out of the box, basically. You don't have to worry about that. You can just keep building with this as you please.
Is it fair to say that the structure here, I feel like there's kind of this conflict sometimes between code versus configuration, especially in research, where you end up having these YAML files, which are like 300 lines long that dictate
100%.
everything. Is the idea here basically that if you want to make some change to your architecture, don't sweat it. Like, don't worry about like class inheritance, yada, yada, yada. Just add a little module in here, set some parameter, kick off a training job.
Dude, nuke this whole thing for all I care. I want you to fork this. I don't want to be in any way dictating how you should code your model. You should just be able to git fork this and do whatever crazy thing it is you want to do. Because the reality is, when we're developing language models, we can't just easily take an existing model and add stuff to it. We often have to like nuke half the code base, re-implement stuff from scratch anyway. My take with this code was, let me create something that is clean, that is simple to work with, that has very, very little dependencies on anything. And that often requires actually re-implementing stuff from scratch because you don't want to have any dependencies on stuff that might break your code. So I went through the painstaking process of re-implementing some really basic modules so that people can then come in and look at the entire code without anything being obscured behind a third-party library. That was my MO throughout this whole thing.
And that's sick, because I feel like most of these pipelines that are kind of done for you either end up being like the PyTorch Lightning, where it hides a lot of these hooks under like a very standard, but like pretty rigid methodology of how you compose your modules. So the second that you have to hook into something that it doesn't support, you don't really know what to do. Or it's something more like Hugging Face, where it has these like class inheritance structures that are so freaking complicated that if you change one thing, the whole thing is going to break. That's much more intended for like inference serving than I think this, which is for research.
Yeah, and look, I mean, I love Hugging Face, right? I love them to death. They're good. They're good guys out there. But the issue is like, they don't know who they're serving. Are they serving the research community or the industry community? And these are two separate types of folks. This is really meant for researchers. This is meant for folks that want to tinker with state-of-the-art things, that want to re-implement crazy things from scratch, that want to try some moonshot project that might require them to, re-implement some stuff and add a whole bunch of custom logic that isn't supported by Hugging Face. It's meant for those folks, right? It's not meant for folks that are just trying to fine-tune some existing state-of-the-art model. This is really meant for the moonshot projects. And so the idea is like, you have this Pico decoder model, you can implement it, you train the model with a training loop that I've built in here, but again, you can create your own trainer. This is just a good starting point to train stuff out. Automatically, it'll do a bunch of the stuff that you might want it to do, like learning rate scheduling, logging to weights and biases, all the basic stuff that you might want to do, advanced checkpointing, all this stuff. But here's the real kicker, Pierce. Once you've trained your model with Pico Train, it'll dump these special checkpoints that are these hooks basically into the model. And so these things will dump out things like, the gradients of the model at certain checkpoint steps or at different aspects of the attention networks, right? And then you can then go in and use the Pico Analyze library and natively basically just plug in the output of Pico Train and analyze all these really cool things about the learning process. So if you've dumped out, for instance, like the activation weights of your model over the course of training, you can use some really cool metrics that I came up with during my PhD, such as something known as the proportional effect of rank, to look at in how many dimensions basically is the model projecting its attention weights onto. So, in a model, typically your model will have, let's say, like 700 and somewhat dimensions, right? The hidden state of the model will be of dimensionality 700 and something. But in practice, even though it has that many dimensions, it won't be using all of them. So the question is like, okay, well, if it has access to 700 dimensions, how many dimensions is it actually using in practice? And it turns out that oftentimes, especially smaller models, will only be using like a small fraction of those dimensions. It's almost like you had an 8-cylinder like V12 engine or something like that, but you only ever use
two pistons
or something like that, right? That's what happens with many of these language models. And so one of the research questions in my PhD was like, how do you measure how many dimensions is a model actually using? How many pistons is it actually firing on? And so in order to evaluate that, I came up with this metric known as proportional effect of rank. And so You can do these analyses and determine how many dimensions is my model actually using. You can also measure how fast the model is learning using this metric known as CKA. You can look at the sparsity of your model using something known as the Gini or the Hoyer sparsity metrics.
And Rich, is some of the latent take here that it's easier to analyze these things after the fact? Because if you look at W and B and you've got like all your different training graphs, yada, 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 I feel like the assumption is that those are pre-baked for you when you kick off your training job. And it's like your model is just going to dump out whatever specific graph you've indicated. Is this common in research communities to say, let's actually just dump as much of the raw, like learning dynamics stuff as possible onto disk and then choose how to interpret it after the fact?
That's what I want to see happen.
That's what you want to see, but it's not something that happens
not the case.
Got it.
Yeah. And here's the kicker, man. I mean, I realized early on in my PhD that nowadays for researchers, storage is effectively free because Hugging Face lets you upload something like 10 terabytes of data for free. So why not just upload a bunch of raw checkpoints to your Hugging Face model, and then you can analyze all of these rich statistics, all of these checkpoints that you've uploaded post hoc and run these really interesting analyses. I think that that is one of the missing things in developing language models is that we just don't checkpoint enough interesting things and we don't run enough post hoc analyses on these statistics that can inform really important parts of the learning process. We don't really know how to measure how fast a model is learning, how effectively it's using its dimensions, how sparse these matrices are. All that stuff is really hard to evaluate if we're not dumping all this checkpoint stuff out during training. So that was one of the things I wanted to see changed. And so that's what this contribution is trying to do. I want to be the change that I want to see in the world. You know what I mean?
Yeah. I'm so proud of you.
Thanks, man. I really appreciate it.
You're changing it. One repo, one fork by one fork.
And so Pico Analyze has already been used by some of the PhDs at Cambridge who I supervised, and they were looking at, they ended up doing some really cool work trying to look at what happens when you train a model on languages for which there just isn't a lot of data. So I had one student look at, for instance, looking at the learning dynamics of a model trained on different types of Philippine languages from the Philippines. So he was looking at Tagalog and Cebuano, like these two different languages, and trying to measure like, okay, well, if you train a model on this language, how fast does the model learn? And if you train on this language, how fast does it learn? And sort of trying to figure out some inherent properties of these languages that make it harder or easier for the model to learn on. So you can do some really cool stuff. And what I would love to see happen is folks start contributing to the Pico Analyze library any additional metrics that they want to use and that they want to see the community start using. And hopefully this can become a big open source initiative for folks to, really double down on the analysis of their models as a really important component of developing these models.
It'd be so cool if this became like Hugging Face has their metrics repo, that it's just a one-click import and then this analyzes any model. Like, it'd be very neat if the end state of this is that any model, there's just a convention for how you dump these raw things to disk. And then this is your way of analyzing that after the fact. Maybe honestly, we wouldn't even really need metrics for anything other than loss. Like, it's good to kill a run, but all of these other supplementary things, maybe we don't actually have to upload it.
And look, man, I think that this could go even further than that. I mean, I think there's a world in which as the model is training in real time, in situ, we have these analyses that are happening simultaneously to the model training that can act as almost like these canaries in the coal mine, as these predictors for whether or not the model is learning well, and can in real time, if they predict that the model isn't learning in a good way, automatically apply an intervention to make the model learn in a better way.
So like what is an intervention, besides just
so I
picking
mean,
off the model?
for instance, right, let's say that you have your model training and all of a sudden you see, hey, something is going on with the loss. Oh, look, with these learning dynamics metrics, we're actually seeing here that certain matrices in these models are actually not using as many of their pistons, so to speak, metaphorically, as many dimensions as they have access to. And we think that this might actually strongly correlate with this degradation in performance that we're seeing. Given that, in real time, what we could try to do is apply an intervention to these matrices. So you could, for instance, start penalizing something known as the spectral norm of these matrices, which literature has shown that this can force models to basically span more of their dimensions. And so you can start tuning hyperparameters or start including these additional sort of like architectural changes to the model in real time, dependent and conditioned on the learning dynamics that are happening in the model at that time. It's almost like when a human is learning something, it's not like you just like are given some set of instructions and you perform the task. Oftentimes you'll have some sort of an inner analysis, like an inner monologue of whether or not you're doing something well. And that will let you learn something in a better way, right? It's like it's almost so obvious that it's trite to say, but humans have this ability to introspect their own learning process and to adapt how they learn something from their own inner monologue. Models have none of that, right? Models have no idea of like how well they're learning. And maybe that's one of these like core missing blocks, right? Like if you could have a model be self-aware of its own learning process, then the model can in real time change its learning process and try different things. And that can, I think, ideally lead us to a world in which models can be continuously learning, can be learning in more effective ways. And I kind of think that that might be one of the missing like stepping stones to AGI, man.
Wow. Big prediction.
I
All
think
because of
so.
Pico Analyze.
Well, and you know, like hopefully the folks that will start contributing to it
Yeah,
in the future.
100%.
Yeah.
We'll get on it, listeners of Pre-Trained.
Yeah. Well, thanks for listening to this pitch, man. I mean, I really wholeheartedly believe that this is something that the community could benefit from. You know?
Oh, I think that this is, I mean, I mentioned it already has 300 stars. You would never toot yourself like that. 400 if you consider both of them together. But like, this just has the building blocks that could pop off. And I think will. I actually think that like one well-placed blog post, like one something, and there's no reason not to use this. Like people always re-implement these training harnesses from scratch. And if you are doing something that involves language modeling, that involves large language modeling, I don't see any reason why this would not be the de facto standard because there's not one like this right now.
I sure hope so, dude.
We'll see.
Yeah. So
nice. Well, thanks
like
for
and
walking
subscribe,
me through.
guys.
Yeah,
Of
like
course,
and
guys.
subscribe. This is fantastic. And maybe more episodes coming.
Maybe
as you
more
look
episodes
into
coming
different
pretty
parts
soon.
of this.
We have some pretty exciting news coming up pretty soon. So I'll keep you
Really?
informed.
Oh,
about the
does.
Pico stuff.
Okay, amazing.
Yeah,
amazing.
yeah.
I was like, what news? Amazing.
Yeah.
Well, thanks for
boss,
walking me through.
thanks for listening.
Yeah, of course.
Alrighty.
Anytime. Till
All right,
next time,
boss.
Rich.
Bye.
Later.